Hi, so this video is intended to get you ready for our Lockout Tagout training next week, and we're going to spend very little time covering the regulations, so I really need you to go onto the OSHA website, look up 1910.147. That's the OSHA regulation for Lockout Tagout. They call it the Control of Hazardous Energy regulation, and in there I want you to learn about the purpose of lockout, which is really for maintenance employees to perform work on pieces of equipment safely. There are some exceptions in the procedure for what they call normal production operation. That includes lubricating fittings and some other things while the machine is in operation. That doesn't put a person at the point of operation while they're doing that, doesn't put them at harm's way. So you can read that kind of stuff. There's different classifications of employees identified in the Lockout Tagout regulation. It talks about authorized employees and affected employees. Authorized are the people who are physically going to be putting locks and tags on energy isolation devices, and affected employees are usually the ones who are not directly doing that stuff but could be operating the equipment. And they have a responsibility to understand the lockout program and what it really means and what the locks and tags mean. The other folks, the affected folks, really need to understand the nuances of the Lockout Tagout procedure and program. The program is the written document that covers and who's responsible for what. The procedure is really the step-by-step thing that needs to happen in order to control the energy for a piece of equipment. The law talks about having specific energy isolation plans for a specific piece of equipment. If you have equipment that looks the same, then you can have one that identifies the procedures for all the equipment that look the same. But before you lock out, before you engage in maintenance activities, a procedural step has to be followed. And that's what you're going to be working on when you come into class, is working on that procedural step, and you'll be physically locking out the equipment. Now we're going to be working in the Johnson's Control Lab outside, and where equipment has liquid inside of it. The equipment can automatically start if you put it in auto. If you press the start button, the equipment will start up. So it's live equipment. We're not working on equipment that doesn't run. So we're going to be physically isolating the equipment. So there's some checkpoints in there for me to make sure that you're heading in the right direction and you don't start up the equipment while somebody is working on it. So I just want to let you know that we are trying to get as close to real life as we can, so you can at least have an example of how you have developed a lockout procedure and how you physically have locked out a piece of equipment, a real piece of equipment. So the Lockout Tagout regulation, in it talks about not just locking out, but what happens in the event that someone puts a lock and tag on a piece of equipment and they're not found. You can't find them. Maybe they've gone home. What's the procedural steps for making sure they're not present before you take the lock off? It's every lock that goes on the device only has one key associated with it, and so that's really the safeguard for that one individual working on that system, is that I got my lock on it, there's only one key, there's a procedure in place that no one's supposed to remove my lock, and when I'm working on it, I have confidence that the equipment will not start up because I verified that I've isolated all the devices and I have a lock on each one of those isolation points. And so the power in Lockout Tagout is the procedural steps. And if you have weak procedural steps, an employee can just take off a lock without verifying, then people are going to lose confidence in the Lockout Tagout process. Control of Hazardous Energy identifies 7 or 8 forms of energy. You can read what those are, but they include electrical energy, pneumatics, hydraulics, potential energy, nuclear energy, and there's a few more. I don't remember what they are offhand, but you can look in the regulation. And before you lock out a piece of equipment, you have to identify the energy sources, write those down, and make sure that you understand the potential for those energy sources. So, for example, if there is a hydraulic water's passing through the system, and so you have to identify what the potential hazard is. So one is water, but under what pressure? Under 50 psi, under 100 psi pressure. There's electrical, there's a motor, there's electricity that goes in the motor. Is it 220, 208 volts? Is it 110 volts? What is the What is the voltage that's going to that system? So what is the potential to cause harm? You have to identify that. And every piece of equipment that you isolate has to be physically isolated. So the regulation, as you will read, it talks about switches and versus a disconnect, like a knife switch that you find that you maybe have on your breaker box at home that isolates your entire box. That physically disconnects that circuit as opposed to a switch. The regulation specifically talks about switches and buttons not being a form of isolation. So be careful when you're out in the field and people will try to convince you that switches and buttons are a positive means of isolation, which they are not according to the OSHA regulation. So the lockout tagout regulation has different types of lockouts that you can perform. You can lock out using locks with tags. You can, if you have positive control over you can demonstrate that tags alone or as an effective means of isolation, you can use tag-only systems. And I've worked in very large facilities where we've had very large lockouts, and we have shied away from tag-only systems because it's easy for someone to circumvent the tag. Really, the whole point of having a lock and a tag on a piece of equipment is just symbolic. It's just let people know that someone's working on the system. Could someone break the lock, cut the lock? Could someone break the lockout device? They could. Symbolic. The thing about what tags is, tags just makes it a lot more, it makes it easier for a person to circumvent a switch or a lever or a ball valve if they needed to. So OSHA really says that if you're going to use a tagging system, that you have to have evidence that that's going to work in your particular case. There's what they call a single lockout. That's when I have a lock on every isolation point. So I had mentioned earlier about electrical. So I have a night switch, I close that off, I put what's called a hasp, which you can put multiple locks on it, and I put that on my isolation device and I put my lock on it. And every other isolation point, like maybe there's a valve that I've turned off and maybe some other valves, I put a lock on each one of those. That's called an individual lockout. So I have a lock on every isolation point. That's an individual lockout. A group lockout is, I might use something called a lockbox. And this is a lockbox. In the lockbox, there's different configurations, but maybe I have locks. And these red locks are all keyed alike. They all have the same key. And they're all stored inside the lockbox. There's 5 locks in the box. This is a hasp where you can put the locks around it. And then with our lockbox, what I can do for a lockbox is I can put all those 5 locks on all my isolation points. I can come back, I can put that key from all those locks, from these locks, which is one key, inside the box. I can close the box, shut it, and then I can put a hasp on the outside of it. And then everyone who's working on that pump or that system puts their lock on the hasp. And I can put more hasp depending on the number of people that are working on the system. So that's called a group lockout, and that's what you're going to be doing when you next week is a group lockout. Group lockouts, the difference is that individual lockout, if you have a whole lot of isolation points, it takes a lot of locks. So if you have 3 or 4 people working on it and you have 10 isolation points, that's a lot of locks. So that's could be expensive and a little bit cumbersome for one person to carry around that many locks and that many keys in their pocket. The group lockout allows you to have a box that has all key-alike locks, and you put on those in the isolation points, and you put that key inside the box, which secures the key, and then you put the hasp on the outside of the box. Maybe you have a string of hasp, and you put people, all they need is just one lock, and they put that on the outside of the box, and they can't open that box with the lock on there because their lock is on the box. So they're still protected by the locks that are on the devices and the keys inside the box. So we're going to demonstrate that one. It's probably the more complex of the lockouts. There is something called a complex lockout, which is even more it's close to group lockout, but instead of having every person have a lock on the box, the complex lockout has a person who represents a large group. Maybe the group is 50 people that are working on this system. Maybe it's a shutdown at a refinery. There's hundreds of people working there. Instead of having hundreds of locks on the box, they have one lock that represents those 50 people. And that one lock is that people still are protected because there's that key inside the box, and that lock that's on the box represents the 50 people. It's really a lot looser than the group lockout. OSHA allows that to happen, but you have to have lots of safeguards, as you probably can figure that it's easy to unlock that if that one person wanted to. You still have the other locks on the box that are protecting the other work groups, but you're not protecting your own work group. So I hope I didn't confuse you on the difference. So there's the individual lockout, group lockout, and then complex lockout. We're going to demonstrate next week the group lockout. You enter the classroom. So first thing I'll do is I'll verify that you've watched the video. May I ask you a question or two about the video? I need to make sure that you have watched this video and you understand what we're going to do. We're not going to review any of the material in class. We're going to go right into the hands-on activity. So I want to make sure that you've read the video, or you've read the material, researched the OSHA regulation, kind of perused that, and have a basic understanding, and that you've seen this video that you're watching right now. The next thing is I want to make sure that you're wearing a long sleeve shirt, long pants, and then you have closed-toed shoes. Those things will get you a pass. In other words, that you'll be able to participate in the activities. If you didn't do the research, the reading, if you aren't properly attired, then you're not going to be able to participate in this activity. Safety glasses, I'll have safety glasses for you to wear. I'll loan you a pair of safety glasses. If you wear prescription eyewear, such as I do, we'll loan you a pair of over-the-glass safety glasses. If you have your own safety glasses, you can bring those in. I'll divide you into groups. So there will be 2 different groups, and within the groups I'll have you subdivide into teams 1 and 2. Each group will have access to a iPad for taking pictures, and there's some video that I'll have on the internet about your particular equipment that you're going to lock out that you need to have access to. I'll provide you with steps for what to do for the activity, and I'll also provide you with a sample program. And the sample program has in it steps for locking out pieces of equipment. So you follow this sample program to set up your lockout procedure. And I'll have some scratch paper and some other things that you'll need to complete the assignment. You'll also have access to lockout isolation equipment, like stuff like this for isolating ball valves. You'll have access to locks and tags and pencils and other kind of things that you need to lockbox, that you need to isolate the piece of equipment. As I said earlier, you're going to be physically isolating the equipment, so you need to follow your procedural steps, and then they'll cue you to letting me know when you're ready to move on to the next step. You will be asked to, when you develop your lockout procedure, you'll be asked to draw a line diagram of your piece of equipment that you're going to lock out. I want it to be really simple, like this, for example. This is an example of a pump, and it's got a line coming inside, and there's a discharge line. There's a valve here and one here. It talks that it has 5 psi water pressure going over here, and then there's 15 psi static water pressure coming out of here. I'll tell you this information. You'll just draw really simple. This is 110 volts for the motor. Really simple, and just label it. And that helps to identify all energy isolations that will need to be, or energy sources going into that piece of equipment. So really basic and simple. I find it being helpful when you're trying to describe to people that are working on a system, so that when they go out they can verify that those are in fact all the energy sources. And they say, what's this line for? And he's like, oh, I forgot this one. This is low pressure air line for something like that. So you need to add that to your drawing and your isolation plan. So I need you to do a basic drawing. Don't have to be